Okay, hey guys, welcome back. We're here with chapter 6.2, and today we're going to look at sketching a linear equation. Now, before we learn how to sketch, we've actually got to understand what a linear equation is. So, what I've got in front of me here is obviously y equals mx plus c. That is our general equation for a straight line. Okay, now what we need to talk about is both the m and the c value. The y and the x here represent, and I'll give you a demonstration now. The y and the x demonstrate the two axes, so the y to the sky is here. The x-axis would be down here or across and down, just like that. Now, the c value the m value I'll start with is the gradient, otherwise known as the slope. Okay, rise over run. In 6.3, we cover a little bit more about calculating that gradient, but I'm also going to be showing you that today as well, how we sketch that gradient. The c value is what we call our y-intercept, and an intercept is where our line crosses over the y-axis in this case. It is possible to have an x-intercept, and a lot of people get confused. They think this m is the x-intercept. It isn't. Okay? That is our gradient. So the thing is, and another way that people always get confused as well, is they might, for example, let's just do a random example of an equation. Y equals 2x plus 1. What this means is we have a gradient of 2. Now, gradient is broken down into rise over run. 2 as a fraction, if I can just express that quickly here, is 2 over 1. So that means that we would have a rise of 2 and a run of 1, and I'll go through and explain that in just a moment. And our y-intercept is 1. In this circumstance. Now, if I were to take this equation, I'll just drop it back to 2 for a second. If I was to take this equation and perform the following, okay, let's say we've got the plus 1 over here. Let's move it over here. This is still a linear equation, okay? We still have a y equals mx plus c. We have an m and a c value. We just might need to rearrange it before we're fully comfortable. In the same process, I could move the 2x over to the other side, make it negative 2x, and we still have a linear equation. Now, with the three methods I'm going to show you, when it's in one of these two forms here, it is a little bit harder to use one of them, and we not like it in a nice, neat, even format of y equals mx plus c. But it's good to know, the different formats that we can have for this one. Okay, now the first method I'm going to show you is the table of values. That shouldn't be an equation editor, but it is. Now, the way that a table of values works is we take a table, obviously. I won't make this too big. We have an x value and we have a y value. Now, the original equation I went through, I know I've just deleted it, I'll quickly put it back. We had y equals 2x plus 1. Let's start with that. Now, this is probably the easiest way to go about plotting. Actually, I should use 0, sorry. 0, 1, 2, 3. This is the easiest way to plot any linear equation, okay? Because as you'll see, a linear equation forms a straight line. Now here, what I've got here is this table's telling me when x is equal to 0, what should the y value be equal to? So here, if I substitute 0 in for x, y is going to be equal to 2 times 0, which is 0. 0 plus 1 is 1. 2 times 1 is 2, plus 1 is 3. Then we're going to get 5 and 7. Now, to prove it's a linear equation, I'd like you to have a look at the y values. Notice how they move up in a common difference every single time. We go from 1 to 3, that's a common difference of 2. 3 to 5, that's plus 2. And then 5 to 7 is also plus 2. An example of when it wouldn't be a common difference would be, say, if it was y equals x squared. So let's take y equals x squared. Let's substitute 0 in. 0 squared is 0, so we get 0, 0. When it's 1, we get 1 squared is 1. When we get 2, 4, it goes 0, 1, 4, already showing that it's not a common difference. Okay? Now, that's how we do a table of values. Now, when we have this table of values, what we effectively have are 4 individual sets of coordinates. So, as an example, we've got 0, 1, then 1, 3. So, going back to my graph over here, 0, 1 would occur here. As you can see, my second one is 1, 3. I'm just going to zoom out a tiny bit. So 0 and 1. Then we had 1 and 3. Okay. Now, if I were to plot them, I'm just going to zoom out a little bit further. Okay, we should be getting a straight line that passes through these 2 points. Now, because it's going to be straight, all of these other coordinates are going to lie on the line. Now, using Desmos, I'm just going to plug this in. And there we have it. Notice how this point here, 0, 1. Okay, when I click on the line, 0, 1, that was my first coordinate. Then 1, 3. Oh, I can't quite get it exactly, but you get the idea. Hopefully it works for me. There we go. So there's 1, 3, and then sure enough, you're going to get 2 and 5, and ultimately there's the 7, and there's the 3. So the points all line up. Now, I generally like to plot 3 of them. Your straight line, if it ever zigzags or curves, you know you've done something wrong in calculating your table of values. And that's how you graph the line. Pretty straightforward and easy. Now, the next method is what's known as the y-intercept and gradient method. And to do this, you take your linear equation, which I've got here, and you start with what's known as, I guess you could call it a starting point. And the easiest way to find a starting point with any equation is with your y-intercept, the +1. So generally how I do the y-intercept gradient method, and using this method you can graph any y equals mx plus c equation in under 5 seconds. Okay, you start at the +1, so I'm just going to delete this. You'd start at the 1 here, okay? Then you've got a gradient of 2. Now, we already broke that down earlier. 2 is equal to 2 over 1 as a fraction. As I said earlier, gradient is your rise over run. That means you're going to, and I'll quickly write this in here. So 2 over 1, the 1 is your run, and the 2 is your rise. So that means you go up 2, and you run across 1. So you'd start here, up 2, across 1, up 2, across 1. So you notice those points I put my cursor on just there. Let's have a look, and you'll see straight away they match up. And I can demonstrate it again. We're going up 2 units, across 1 unit, up 2 units, across 1 unit. Okay, and that's our gradient y-intercept method. Very simple and easy way to do it. Now, I know this is kind of a bit of a dog leg, but let's change this one up a little bit. Okay, let's say that we had a gradient of negative 3 over, let's go 2. Okay, let's make the y-intercept plus 3. So using this, again, our starting point is going to be the positive 3, just up here. Now, what we've got is a rise over run of negative 3 over 2. Now, this negative you can apply to either the 3 or the 2. It doesn't matter, as you're about to see. And let me prove that to you. Let's say that we apply the negative to the 3, so it becomes negative 3 over 2. What that means is you will go down 3 and then across 2. So just to reiterate, we started here because that was our y-intercept. We go down 3 and across 2. And that actually crosses perfectly at the 2 on the x-axis. Now, if it was the other way round, we had 3 over negative 2. Because we're going positive, we still go up 3. Well, sorry, we change. We go up 3 this time. Instead of going across 2, we would go back 2. Now, I want you to watch these 2 points. So I'll just zoom out a bit further so we get it. I mentioned earlier, so there's the 3. Doing the negative 3 first, we went down there. Otherwise, we'd end up over here. We'd go up 3, then back 2, which would lead us here. Now, watch what's going to happen. Y equals negative 3 over 2x plus 3. Notice how both the points are there, either up 3, back 2, or down 3 and across 2. They both give you points, and they all lie within our line, our straight line, and as you can see, that will go on forever. It has no limits to it. It has no end. at this point in time. So that's how you apply a negative fraction and negative gradient. Okay, that is our y-intercept / gradient method. And remember this here, this 3, I just realized I'm going to put in, this is your starting point on the y-axis. That might make it a bit easier for people to understand when they look at these notes. Now, the final method, instead of using the gradient, we're going to use the y-intercept and the x-intercept method. Now, you're probably sitting there thinking, okay, how do I go about this? Well, what we do is we take our equation again. This time I'm just going to use the y equals 2x plus 1. Okay, we get y equals 2x plus 1. Now, we know that the y-intercept was positive 1. Okay, you don't need to put the positive there. We're just going to write 1. Okay, no calculations needed for that. Okay, that's very easy to understand. Now, we knew that because that's what I explained with y equals mx plus c. The c will always be your y-intercept value. But when does an intercept actually occur? Let me just show you back here. This intercept, this coordinate I should say, occurs when x is equal to 0. So if we look at our intercept over here, it occurs when y equals 0. So to find the x-intercept, interesting, I'm not spelling that wrong. The x-intercept occurs when our y value equals 0. Oops, that's not a 0, that's a 0. So what we do, we take our equation, and what I'm going to do is substitute y equals 0 in. Okay? And then I'm just going to rearrange it. So it's going to be 0 minus 1 is negative 1, moving the 1 to the other side. What it's going to become is negative 1 over 2, or negative a half. So, just to prove it, this is not the equation we're looking at now. It's y equals 2x plus 1. So, we already mentioned earlier that the y-intercept is 1. You can see that there. And the x-intercept, there you go. Proof is right there. Negative 0.5 or negative a half. Now, if you're wondering, you can actually do the same up here because, as I mentioned earlier, you're not always going to get a perfect y equals mx plus c. You might have to rearrange it. It could be y minus c equals mx. You know, y minus mx equals c. Okay, you could end up with a whole different ranges of linear equations, as you're going to see. But there's the starting point for that one. Okay, that's how you graph each of these. Now, the important thing to know, and I should put this up here as well, for the x and y-intercept method, the y-intercept occurs when our x value equals 0. And that's going to be important to know for some future questions. Speaking of questions, let's go to the textbook and let's have a look at some of these. So, we're starting with 6.2 here. We've got the first worked example here. State the gradients and y-intercepts of the following linear equations. So gradient for this one will be 5, or 5 over 1, and the y-intercept to be 2. For this one here, the gradient, now it's x over 2. X over 2 is just equal to 1/2 times x, or half times x. So the gradient is 1 over 2. Don't stress about fractions. It's actually easier to do a fraction than it is to do a whole number. Just for the simple fact that it's already in fraction form for you. Here we've got a y-intercept of 4 and a gradient of negative 2. Now, this is where some students might get confused. Let's do this one on our little example. So what are we doing? We are just going to copy and paste this so you've got those who can't access the video for whatever reason can at least see what I'm working out here. Say the gradients. I'm just copying this too. So state the gradients and y-intercept of the following linear equation. And what we had was 2y equals 4x. So the gradient is currently 4, but it actually isn't, as you're about to see, plus 3. Now, what makes this difficult is we have this 2 in front of the y. It's been applied a scale factor of 2. Now, to get rid of the 2, we're going to move it to the other side. We're going to put these in brackets just very quickly, just so the equation editor cooperates with us. And we're going to move it over here. So all I've done, going from one step to the other, is turn that into a divide by 2. Okay? What that is then going to equal, just using our knowledge of how fractions work, is going to be... So, there we go. It's actually going to be 4x over 2 plus 3 over 2. From there, we can simplify it down to a linear equation of y equals mx plus c. You can leave it as 3 over 2. You can change it to 1.5. Whatever works for you. I'm just going to put it as 1.5. That makes our y-intercept 1.5 and our gradient 2. Let me just demonstrate that very quickly on Desmos using the original equation. So even if you put it in, straight away it shows you the y-intercept is 1.5 and the gradient should be 2. Let's find out. So to run across 1 unit up to this line, we go up 1, 2, and across 1. There we go. So the gradient is still 2 for that one there. So that's how you state the gradient of y-intercept for that linear equation. Now, going back to the last one, I'll show you how to do it for this one as well. So I'll call this A, and we'll do B just down here, just so it doesn't look like we're doing both of them together. We get 3y minus 4x is equal to 12. Okay, so what we're going to do, similar to the example just above, we're going to rearrange this to make it 3y is equal to plus 4y. Okay, now you'll notice straight away that it isn't in the form of y equals mx plus c, it's y equals c plus mx. That's okay, but just to make it easy, you can rearrange it if you wanted to get the following. There you go. Now it's in y equals mx plus c. Now we just need to get rid of the 3. Using the same process up here, what we're going to do... Sorry, I just realized I put... Sorry, yeah, that should be x. My apologies, guys, for those watching the video. Using the same process I did above, we're going to divide, just to save some working. 4x divided by 3. 12 divided by 3 is going to be 4. And there's your equation. So the gradient, if you wanted to... Sorry, I should rearrange it this way. There we go. So the rise over run, or the gradient, is 4 over 3, which means we go up 4 units across 3 units as our gradient, and our y-intercept is 4. So there you go. That's how you state the gradient and y-intercept for this one. Now, going down to worked example number 2, we have determined the values of the gradients of the following graphs. Now, I'm not going to put this in the slide here. This can be a bonus for the video. There is a formula we're going to do next video, but for now I'm going to show you how you eyeball it. Okay. Now you can see here, what you want to do is look for 2 clear points. I'll zoom right in on A first. If you, for example, tried to use this point here, you would be estimating, and you're not going to get a very clear answer. But they've purposely done it in a very easy format for us, to the point where if you run your cursor, or your, most of you should be doing this on a computer, your cursor along, you'll see that you have a clearly defined coordinate here, and you have a clearly defined coordinate up here. Okay, the coordinate here would be -3, 0, and this would be 0 and 4. Now, what you need to think about is, how did I get from here to here? Now, gradient is your rise over your run, so you're forming a little triangle here. Okay? So, our rise, to get from this point to this point, we've gone up 1, 2, 3, 4, and across 1, 2, 3. That makes your gradient 4 over 3. It's positive because it's increasing in both directions. The way I know the difference between a positive and a negative, you're about to see a negative, but I like to think of the stairway to heaven being positive, and then you've got the highway to hell. So we know this is going to be a negative. Now, when you read a graph, you should always be reading it like a book, so from left to right. So in this case, we start from here and we're going to go down here. As you see, as I run my cursor along, we've got the two clearly defined points on the axes, or the intercepts on each axis. We shouldn't need to, it doesn't always have to be on the axes, all right? It can be wherever. If we had a perfect point, say, here, we could use that one. Anyway, we've got 0, 4, and then 5, 0. So I've gone from here to here, reading it like a book, left to right. Some students go, oh, it's positive because we're going from here up to here. You're not. It's like a book, left to right. So what we do is we're going down 1, 2, 3, 4, and across 1, 2, 3, 4, 5. That gives you a gradient of -4, because we're going down 4, -4 over 5, or -0.8, because if you put 4 over 5 in your calculator, you'll get 0.8. So -0.8 would be our gradient for that one. If we have a look at what the textbook does, I just want to see what they gave it as. They gave it as 2 over 3. Wait, no, it's a different one, sorry. There it is, -4 over 5, or -0.8. Okay, for our final example. Looks like they do jump into the formula straight away. So I'll actually just go through the first one here, because I know this video is actually getting quite lengthy. Just quickly pull that back onto the previous page. So what this question is asking us to do is to determine the values of the gradients of the linear graphs that pass through the following points. So we've got 4, 6 and 5, 9. So the first thing we need to do with one like this is to mark the different coordinates. Now, there's a generic formula that we can use to find the gradient, and it's as follows. M equals, just quickly getting rid of these, sorry, y2 take y1, and I should be using subscript for that, I apologize, over x2 minus x1, or the change in y over the change in x. Now, what we have to do is we have to look at these and we have to label them. We've got 4 coordinates, which is which. Now, first of all, you need to think to yourself which coordinate will appear first on our line. Now, remember, we read from left to right. When we have a coordinate, we know that this value here is going to be an x value, and we know this is going to be a y value. Similar with this one, we know that this is also an x value, and this is also a y value. That's not new information for you. But which one is x1 and which one is x2? Realistically, in this case, it doesn't actually matter. It's going to give us the same answer no matter how we do it, but it's still good to know for practicality reasons. Well, which would occur first? X is 4 or x is 5? When in doubt, let's go back to our graph. Well, you read from left to right. 4 would occur first. So this is your x1. This has to be y1. This is x2, y2. From there, we substitute. So y2 we identified as 9. y1 we identified as 6. x2 we identified as 5. And x1 was 4. What that's going to do, I'll just simplify it one more time. 9 minus 6 is 3. 5 minus 4 is 1. 3 over 1, you can keep it as a fraction, but because it's a whole number, we can literally just write it as 3. And that's how you determine the gradient when you're given 2 coordinates. Okay, now what you're going to look at next video is how to actually take 2 coordinates and form a linear equation line. Okay, but for now, we're just keeping it pretty simple. Next up, let's go back to the worked examples. So here we go. So this one is construct a linear graph that passes through the points -1 and 2, 0, 4, 1 and 6, 3 and 10. They didn't need to give us all 4 of those points, but they have. Using technology, I would expect you to use Desmos. We don't use graphics calculators here. Without technology, literally just plot them, and as you can see, that's going to form a straight line. They've missed the point in there, but that's okay. Doesn't make a difference. All right, that's how you do worked example 4. Now, going forward, I've got one, I believe one. I'll just double check. No, two maybe. So I'll just do one of these using the gradient and y-intercept method. So I'm just going to copy this in. Now, this one I won't actually copy into that document because it's something that is kind of hard to express, without actually watching a video. So the gradient y-intercept method, if you remember from before, that's where you start at the y-intercept, that's your beginning point, and then you use the gradient to sketch it. Now here, you've got y equals negative 2x plus 4. All right, so the way you would go about doing that, if you had your blank grid paper like this, our starting point is positive 4. So you would start here. Our gradient is negative 2. Now, negative 2 as a fraction is negative 2 over 1. That means we go down 2 and across 1. So first of all, just pay attention to these points I'm marking. The 4 on the y-axis, and then negative 2 over 1. So you'd go down 2, across 1. Down 2, across 1. Notice this point and this point here. That's where it's going to cross. To double check, y equals negative 2x plus 4. And sure enough, there you go. Down 2, across 1. Down 2, across 1. That's our linear equation for that one. So that's how you do worked example 5 using the gradient and y-intercept method. Finally, calculate the value. This one I will copy into the document. This is a very important one because it always trips the students up. Just going to quickly go down. Here we go. So the question is asking us, calculate the value of the x and y intercepts for the following linear equations and hence sketch their graphs. I'm not going to do all of these. I'll do that, weirdly enough. Interesting. I actually think the hardest one here is actually the first one. So I'm going to go through and do that now. Now what I'm going to do is I'm just going to copy and paste these very quickly. This one. So we know, and I'll just quickly write the graph in. So what was it? 3x plus 4y is equal to 12. This is without a doubt probably the hardest one to do straight away. And I'll copy that down here as well. So we know the y-intercept occurs when our x value equals 0. Now, if you wanted to take the time, rearrange it, and go, there's our y-intercept, now I'll sub 0 in for y and get our values, you can do that. Nothing's stopping you. You're still technically following it. But you don't need to rearrange it. Okay, I'm going to prove that to you. So we have our equation here from the worked example. Substitute 0 in. Okay. Oops, sorry. I'll put the time symbol. And now what we can do is we can find our equation. 3 times 0 is 0, so 0 plus 4y is going to be 4y. That's going to leave us with y equals 12 over 4. And we're going to end up with y is equal to a grand total of 3. Okay, so there's your y-intercept. It's equal to 3. Now, over to the next one. I might actually just copy and paste this whole thing. Probably going to be easier. So what we know with the next one is that the x-intercept occurs when our y value is equal to 0. So that's what I'm just subbing in. Now, 0 for the y value. That's going to give you 3x is equal to 12. That means the x-intercept in this circumstance is going to be 12 over 3, which gives you a total of 4. Now, when you know the two intercepts, it's just like plotting a line given 2 points. Okay, once you have 2 points, you can plot the whole thing. So going back to Desmos, getting rid of this graph. To graph this one, the y-intercept is 3, just here, and the x-intercept is 4, just down here. Please take note of these 2 points here. Now, if I take that equation at face value, okay, not rearranged, look what happens. It lines up perfectly, doesn't it? Grade 11. So, that's it for this video, this worked example. I know it was a very, very long one for you guys, but there's quite a lot to unpack with this, okay? You'll find the other videos are going to be a bit shorter. Thanks again, guys.